Hey guys, so I'm going to show you in this video how we would solve the limit of a problem like this. So for this, we have the limit as x is approaching 1 of the square root of x plus 3 minus 2 over x minus 1. So looking at this problem, we're going to see what would happen if we plug our a value in, and again, this is our a value right here. So if we plug in this a value, we would have is equal to the limit as x is approaching 1 of the square root of x plus 3 minus 2 over x minus 1. We would have 1 here and 1 here. So in the denominator, if we have 1 minus 1, this would be equal to 0 in our denominator. So this would be the square root of 4, which is 2. So this would be 2 minus 2 over 1 minus 1, which is equal to 0 over 0. This is not considered a defined answer. So this is undefined. We cannot have 0 in the denominator of our function, meaning that 1 is not in our domain. Since 1 is not in the domain of our function, it is not an x value that we can plug in to this original function. So 1, if you guys were asked to find the domain of this function, 1 would not be in this function's domain. So just know the definition of that, and then I'm going to show you guys how you could solve this, since we can't use direct substitution. So there is something that we can use, because looking at this problem, when we have the limit as x is approaching 1 of the square root of x plus 3 minus 2 over x minus 1. Looking at the problem when it's written like this, obviously we can't use direct substitution. So we're not going to use direct substitution here. So we can cross that out. It's kind of hard to see like what you could really do with this problem, because you don't really want to cancel out the denominator, because that seems like a lot of work. There's not really a ton of steps you can take that'll make a lot of sense. Sorry, I had a yawn. There's not really a ton of steps you can make a lot of sense to get to an answer. The best step that we're going to do here is multiplying by the conjugate of the problem. Not of the problem, multiplying by the conjugate of our numerator. So this is going to be the best step that we can take. And basically what a conjugate is, if you guys aren't sure, if you have a conjugate of a binomial, say you have x plus y as your function, the conjugate of this is going to be x minus y. Basically what it means is that you flip the sign between the terms of your binomial. So if you were to have x minus y as your function, your conjugate of this would be x plus y. If you have a conjugate of a polynomial, so if we were to have x squared plus ax plus b squared, the conjugate of this would be x squared minus ax minus b squared. And then if we were to have, say, x squared minus ax plus b, this would be equal to x squared plus ax minus b squared. So make sure you feel familiar with the definition of a conjugate of a binomial product or a polynomial. So going back here, we're going to multiply by the conjugate of our numerator. So the conjugate of our numerator is the square root of x plus 3 minus 2. So the conjugate is going to be the square root of x plus 3 plus 2, because we're not going to change the sign inside of our square root. And then what we do to the numerator, we also have to do to the denominator. So we have x plus 3 plus 2 in our denominator as well. So now looking at this problem, what we now have, we have the limit as x is approaching 1 of the square root of x plus 3 minus 2 times the square root of x plus 3 plus 2, all divided by x minus 1 times the square root of x plus 3 plus 2. So now working this out, we're going to distribute in the numerator. So in the numerator, we're going to have the limit as x is approaching 1 of the square root of x plus 3 times the square root of x plus 3. Because we distribute here, and then we have minus 2 times the square root of x plus 3 plus 2 times the square root of x plus 3, and then negative 2 times 2 will be minus 4, all divided by x minus 1 times the square root of x plus 3 plus 2. And I know right now our numerator looks super crazy, but what we're going to see is we're going to see some things starting to cancel out, and it's going to start making a lot of sense for our problem. So if we have x plus 3 times x plus 3, when we have something times itself, you're just squaring it. So we're going to have the square root of x plus 3 squared, and then minus 2 times x plus 3 plus 2 times x plus 3. Well, those two things cancel out. So then we're just going to have this minus 4 divided by x minus 1 times x plus 3 plus 2. And so now if we have the square root of something squared, that square root cancels out. So going back to our problem, we have the limit as x is approaching 1 of x plus 3 minus 4 in our numerator divided by x minus 1 times the square root of x plus 3 plus 2. So looking at this problem, I know that if I take 4 away from 3, I'm going to end up with negative 1. So now I'm going to have the limit as x is approaching 1 of x minus 1 over x minus 1 times the square root of x plus 3 plus 2. So the numerator now cancels out with the denominator, and so now this is starting to look like one of those problems where we start canceling things out and we start getting to a point in the problem where we can plug in that a value. So these problems are a little tricky in the beginning because what you have to do is you have to multiply by the conjugate. When you see a formula or a function in this type of format, sorry guys, I'm tired today. When you see this function in this type of format, you're going to see that you're going to first multiply by the conjugate, and you're going to get some stuff that's going to cancel out. You're going to get stuff that's going to cancel out with each other in the numerator, and then eventually you're going to get stuff in the numerator and the denominator that cancel out with each other. So you're going to get to a point where now we can plug in that a value and we actually get a defined answer. That's the whole goal of these problems, trying to get to a point where we can get a defined answer. So now we're going to have 1 over the square root of x plus 3 plus 2. Now we're going to plug in that 1. This is equal to 1 over the square root of 4 plus 2, which is equal to 1 over 2 plus 2, which is equal to 1/4. And this should be the answer for this problem. If you guys were to see something like this on the exam, you end up with 1/4.